What's up, everyone? This is Liz from SoCal Indie Hacker. We're back here in the Learn C# with Me series. It's part 3 of this series. If this is your first time here, I'm documenting my journey to learn the C# programming language because I want to learn more about games, making games, publishing them, and all that good stuff. Now, as far as the high-level plan, I'm starting with C# and then we're going to move over to Unity and get the foundations over there. Unity is, of course, a game engine known for being especially good with 2D games. At the tactical level, we're going to push through this first module for the C# Foundations course. It took me a little getting used to it first with the dual platform setup between freeCodeCamp and Microsoft, but I get it now. This module in particular is covering basic info in C# regarding variables like basic operations on numbers and strings and just some other fundamentals. The mini project for this particular module is a simple GPA calculator, but maybe we can find some other ways to jazz it up, like adding some persistent like data store or year-over-year statistics or something like that. Okay, let's hop in. Okay, so we're going to be going through the introduction of the string formatting section. As a software developer, you'll need to write C# code to combine and format literal and variable data to create new values. The values might be displayed, saved to files, sent across the network, and something like that. Fortunately, C# provides many ways to combine and format data. Suppose you want to display the output of a command line application you're writing. You want to display values including literal text, text in variables, numeric data, and the textual data in other languages. How would you format it correctly so the user can understand what your application is communicating to them? In this module, you'll use character escape sequences to format literal strings of text to include special characters, including tabs and line feeds. Even from different languages like Kanji or Cyrillic script. You'll learn how to concatenate two strings together, and we'll use string interpolation to create literal string templates with replaceable parts. By the end of this module, you'll be able to control how your data is displayed to end users of your applications. So for the objectives, so strings with special characters and tabs, handle Unicode, concatenation and interpolation. Okay. Alright, combine strings using characters and using character escape sequences. So suppose you've been asked to create a mock-up of a command line tool that will generate invoices in both English and Japanese. You don't have to build, okay, so it's just a mock-up. No business logic yet. Okay, your manager asks you to make sure to add formatting to make the current progress of the tool clear. And Japanese. So we're talking about literal string formatting. So escape sequences. So backslash. Let's see. An escape character sequence is an instruction to the runtime to insert a special character that will affect the output of your string. In C, the escape character sequence begins with backslash, followed by the character you're escaping. So we have new lines and tabs. So that would put it on 2 lines. We'll actually put it on 2 lines and then put a new line implicitly here at the end. So like hello world, hello world. Oh, that was a tab, a T. So hello world, hello world. If you run the code, you'll see the following output. So what if you need to insert a double quotation mark in a literal string? If you don't use, okay, so yep, just have to escape quotes within quotes. otherwise throws a syntax error. Should show up as an error in editor. Yep, there it is. If you escape it, you'll see the correct text. Squigglies disappear, and you'll see the correct text. Okay, and then you have to escape backslashes. So double backslash. Yep. Got it, got it. Format output using the escape sequence. Okay, so quotes within quotes, new line, so it'll double new line, so it'll make a space between these two, and then a tab space, double tab here, so invoice number, double tab status, invoice number, double tab status, and then an extra space between these two and a tab at the end. Yep, that looks about right. Oh, there it is. Verbatim string literal. Verbatim string literal will keep all white space and characters without the need to escape the backslash. To create a verbatim string, use the directive before the string literal. So slightly indented. Next line, but not indented. Nope, still indented. So it will, even on the next line, understand this is the double tab. So 4 spaces, 8 spaces, which would push it to, yeah, here. Okay, that makes sense. Format output using verbatim string literals. Add this under the code you created previously. Console.write verbatim string invoices. Oh, cancel. So then this will be all the way back here. Oops, here. Because this got indented. So 1, 2, 3, 4, 8, 0. 4, 8, 0. Oh, I guess I was supposed to keep all this stuff from before. Okay. Unicode escape characters. You can also add encoded characters in literal strings using the Unicode escape sequence. Then a 4-character code representing some character in Unicode. Konnichiwa world. Okay, those are the actual characters. Gotcha. There are several caveats here. Some consoles, like Windows Command Prompt, will not display all Unicode characters. It will replace those characters with a question mark instead. Also, the examples used here are UTF-16. Some characters require UTF-32 and therefore require a different escape sequence. This is a complicated subject, and this module is only aiming for showing you what is possible. Depending on what you need, you may need to spend quite a bit more time learning and working with Unicode characters in your applications. Fair enough. Format output using Unicode and escape characters. To complete the mock-up of the command line tool, you'll add the phrase in Japanese that translates to generate Japanese invoices. Then you'll display a verbatim literal string that represents a command the user can enter. Also add some escape sequences for formatting. So I'm not going to try to manually type in all of that. Do you not okay, so let's go back to that. So these are the Japanese. So we have the header explaining what's happening, the invoices, the output directory, and then the instructions for the alternative Japanese command. New line. So down 2 lines. And then okay, because there's a tab at the end. That's why this got pushed in. Gotcha. Okay. So the main thing is that the @ symbol is the verbatim string. Alright, so yep. Character escape sequences, verbatim string, literal, Unicode. Combine strings using concatenation. Often you'll need to combine data from many different sources, including literal strings and variables, both containing text and numeric data. In this unit, you'll use string concatenation to combine 2 or more values into a string. What is string concatenation? Since concatenation is programmers speak for simply combining 2 or more string values into a new string value. Unlike addition, the second value is appended to the end of the first value and so on. In the following exercise, you'll write code to concatenate string values together. Concatenating 2 strings, you use the string plus to concatenate. Got it. I'll clear this out. So oops. Trying to be cute here. First name, yep. Tried and true message. Close. It's not going to predict that? Okay. Fine, whatever. hello person, concatenate multiple strings and literals. So yep. String variable to string literal to variable to string literal. Avoiding intermediate variables. And the previous step, you used an extra variable to hold the new string that was resulted. Okay, so yeah. So no need to have like a separate message. You can just concatenate everything within the method invocation. Yep. So concatenation plus. Combine strings using interpolation. Got it. What is string? Well, no, while string concatenation is simple and convenient, string interpolation is growing in popularity in situations where you may need to combine many literal strings into variables into a single. I can't read. While string concatenation is simple and convenient, string interpolation is growing in popularity in situations where you need to combine many literal strings and variables into a single formatted string. What is string interpolation? String interpolation combines multiple values into a single literal string by using a template and one or more interpolation expressions. So a template and an interpolation expression. An interpolation expression is indicated by an opening and closing curly brace symbol. You may put any C# expression that returns a value inside these braces. The literal string becomes a template when it's prefixed by a character, $sign character. So instead of doing this thing where we have variable holding string concatenated with string literal, concatenated with variable holding string, concatenated with string literal, we can make this template that holds two interpolation expressions, and the interpolation expressions just hold variables. Got it. And this having a $sign at the beginning is what makes this a template. Okay. Alright, so in this example you save a few keystrokes. You can imagine how much more concise string interpolation can be in more complex operations. Moreover, many find the string interpolation syntax cleaner and easier to read. In the following exercise, you'll rewrite the previous message into string interpolation. So say we had this, then yeah, we're just doing like just gonna do a $sign and yeah, double quotes. So greeting and first name, and then with that, then we just need a greeting. We don't even need the space. And we're going to call this greeting, and we're good to go with no exclamation point. Need to add an exclamation point, and then we're good to go. String interpolation with multiple variables and literal strings. So you perform string interpolation operations in the same line of code. So we have an int update to Windows, so it will automatically handle converting this int into a string. Okay, cool. And then they're saying just avoid the intermediate variables. Yeah. Yep, okay. Combine verbatim literals and string interpolation. So verbatim literals meaning strings that will, what do we want to think of that as? Verbatim literals, strings that preserve white space. So here's the thing. So, because I was like looking at Python, I think that just preserves white space by default. So we're saying this won't. So it already just preserves the white string. Why do we need a special character? Or is the idea that it won't preserve? The new line. I think that's what it is. Yeah, okay. It will let you break across lines. Okay, I just need to get that squared in my head first. All right. So verbatim literals let you, it preserves the literal line breaks. Mainly the literal line breaks, yeah. Suppose you need to use a verbatim literal in your template. You can use both verbatim literal prefix symbol and string interpolation. Oh man, symbols together. Okay. So there it's saying, hey, you can have the C. Oh, okay, and then you also don't have to escape. So verbatim literals let you not have to escape. And it will break across lines. Okay. I don't even know if this is right, but just is what it is. So it would support that. And then without that, you're going to get errors. All kinds of errors. Yep. All right. Cool. Yep. All right. So verbatim literal and string interpolation. Got it. So recap. String interpolation provides an improvement over string concatenation by reducing the number of characters required in some situations. And you can combine string interpolation and verbatim literals by combining the symbols. Okay, complete the challenge. Code challenges will reinforce what you've learned and blah blah blah. In this challenge, you'll print instructions to end user to let them know your application will output data files. You won't actually be creating any files. You're only interested in displaying the format instructions to the console window. You'll use what you learned about characters and character escape sequences, verbatim strings, Unicode, and string interpolation to provide instructions in both English and Russian. Format and display instructions. Clear the code. Okay. Begin solving the challenge with the following 2 lines of code. So the project name is Acme, and then the Russian message is that. The project name variable will be used twice in the desired output. The Russian language message contains a message, view Russian output in Russian. You must use this variable in your code that prints the message. You may not change these 2 lines of code, but you can add code above and below each line. You must use these 2 lines of code to form the desired output. You can only use write line or write. Okay, no more than twice. Oh, okay. Use either write line or write twice. In other words, to complete this challenge, you can only create 2 instructions that actually print output to the console. Okay, so you have to, no more than twice can you use these. If you need to print additional new lines or add any formatting, you must use what you've learned in this module to accomplish it. The character escape sequences, verbatim strings, and Unicode and string interpolations to use those things to generate the output. To complete this challenge, your code must produce the following out. Okay, so view English, and then the path, and then view, then the Russian message, and then the path. Take note of the new lines, tabs, and how the 2 mandatory lines of code are used in the output. Whether you get stuck and need to peek at the solution or you finish successfully, continue on to view the solution to this challenge. Okay, so blah 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 blah. So we're going to need the name of the project in both places. Why is this editor hanging, freezing up? Not that. Alright. So if we can only use the print twice, then we'll break them. We'll use a /n. Or not even /n, we'll use just literal string. Why is this thing hanging, going slow all of a sudden? The Russian message. We'll call this the English message. So the Russian message is already defined, and then path. And so that's actually almost the same, but with a RU. Yeah, don't. So we're going to do this as English message. English path. And let's try that. And then we can do the same with Russian message, Russian. There we go. Over the D, over the slash, over the D. No, it's not over the D. And that's not over the slash. Oh, so 2 spaces. Okay, over the D, over the slash, over the D, over the slash. Alright. Cool. Following code is one possible solution. So we got the project name and then string location. Okay, so they did not use verbatim literal here. They used escaped white space. Okay. And here they also used escaped white space. Okay. Knowledge check. Which of the following should be used to add double quotes? Which of the following uses interpolation, assuming that the variable value is a string? Unicode characters are embedded in C# strings for a console application to present a greeting message in Thai. However, this message will only display question mark characters. What is the cause? User's console does not support Unicode. Wrong Unicode or doesn't support? Because the issue is that it doesn't support those Unicode characters. Which of the following, like maybe the Thai is in UTF like 32 or something, but it only supports UTF 16, I think. Yeah. Which of the following lines of code appends a single slash to the string directory? Literal. Yeah. What? Talked myself out of it. Okay. So okay, we're back to the next module, and this is about performing operations on numbers in C#. So, basic math operations on numeric data. Mathematical operations observe implicit type conversions between strings and numeric values, and temporarily convert one data type into another. Okay, in this application you'll build in C#. This application you'll build in C# will require you to operate on literal and variable numeric data. So we could see situations where we're doing like basic arithmetic, addition, subtraction, multiplication, division, do multi-step operations that must be completed in a certain order. We can determine the remainder after performing division, so modulus operations, and incrementing or decrementing. Suppose you want to perform a calculation that converts a value from one unit of measure to another. For example, oh god, temperature conversion. Okay, suppose you want to go from Fahrenheit to Celsius. Once you've calculated the temperature in degrees Celsius, you need to display that information in a formatted message to the user. To accomplish this, you'll need to learn how to use operations to act on operands like literal and variable values. In this module, you'll perform a basic string and numeric operations on your data. As you'll learn, the compiler will perform different tasks depending on the data types of the values given around the given operator. More importantly, you'll come to understand how operators perform actions on operands. Learning to work with operators and operands correctly will help you formulate meaningful instructions in your code. So by the end, you'll be able to write a code that performs basic operations on literals and variables. So mathematical operations, type conversions, understand what those do, and converting types. Alright, so we're performing addition. So you'll want to perform mathematical operations on numeric data. You'll start with addition in this unit. So we're just adding. Add two numbers. I'm gonna summarize some of this stuff. So we're just adding. Adding always involves the plus symbol. The reuse of one symbol. Oh, okay, so there's talking about overloading. So they're saying when we're talking about numerical values, the plus sign means addition. When we're talking about strings, it's concatenation. So we can say that the plus sign is an overloaded operator. It has multiple uses depending on what it's used on. In this instance, the compiler understands what you're attempting to do. So it can tell like what's being added. It sees two numbers, it knows what to do. It sees two strings, it knows what to do. Presumably it's going to wig out if it sees like a number and a string. Okay, so I can't even tell it, like, can I? Yeah, it's like gonna be like, what? Yeah, because it can't cast the string to the end. Does it always try to cast whatever the second thing is? So does this mean it's going to say can't cast int to string? Nope, it always, so there must be some kind of precedent because it always tries to cast string to int. Alright, so compiler knows what to do based on the types of the operands. Mixed data types will force implicit type conversions. So interesting. It will, if you just try to add this and cast it to, or put it in a variable, it can't cast. But if I want to write, if I want to write this, will it know what to do? There it will know what to do. So it's not just the operands, it's also what kind of action is happening. Because it knows, okay, this what it interprets as arithmetic, but this it knows as printing. Okay, what happens if you try to use the plus symbol on ints and strings? So because we're writing, it doesn't have a problem. In this case, the compiler understands that you want to use the plus symbol to concatenate the two operands. It decides this because the plus symbol is surrounded by operands of type string and int data types. So it attempts to implicitly convert the int variable to a string. I mean, it's also surrounded that way here. I think there's something else happening that it also factors in, whether it's in a method or what kind of method. It's got to be. Attempt a more advanced case of adding numbers in concatenated strings. So Bob and 7, okay, 77. So yeah, it's the same thing. It knows when to push a number up against a string. Using parentheses to clarify your intentions to the compiler. You know what? Maybe that'll make it not that's what makes it not wig out. Because here it's like I'm telling it, okay, into a type string, which presumably console, like again, it knows it's working with a string. Yep. Add parentheses to clarify your attempt. Blah. Modify. Yes. Add parentheses to clarify your intentions to the compiler. Modify the code you wrote to match the following code. So we can tell it, hey, these two definitely need to go together. Oh, it needs to add them together. Putting parentheses around it tells it to do this as arithmetic. That's interesting. Parentheses symbols are another overloaded operator. In this case, the opening and closing of parentheses form the order of operations operator, just like you might use in a mathematical formula. Okay. Because when we close them here, this is going to run or be evaluated first. And the compiler sees a number and a number, an int and an int. So it will sum them to an actual int, which will then just go into the flow of concatenation here. You indicate that you want the innermost parentheses resolved or evaluated first, resulting in the addition of int values, widgets sold, and value 7. Once that is resolved, it will implicitly convert the result to a string so that it can concatenate the rest of the message. yeah, and then said, don't do that. Avoid performing both a calculation and concatenation in a single line of code. The point here is to help you understand how to view order operators and operands the way the compiler does. Fair enough. Okay. So you can perform mathematical like addition operations on numbers, both string concatenation and addition use the plus symbol because it's overloaded. The compiler will try to implicitly convert things to you, or convert types for you. And parentheses define an order of operations. Now that you understand the basics of addition and more importantly implicit type conversion between numeric and string data types, let's look at several other common mathematical operations on numeric data. Okay. Write code to perform addition, subtraction, and multiplication. And alright, so we're going to get a result of numbers here. So 12 to 35 and some kind of float, 1 point, I don't know, something. And so they're numbers, so we should be able to cast fine. We'll see what happens with this because it's a float. So this is 1 point something, and then in here it probably cast it to an int, which made it round down to 1. Yeah, resulting quotient may not be what you've expected. Decimals are truncated. So not rounding, it's not rounding down, it's just cutting it off. Add code to perform division using literal decimal data. Okay. What did M? M means decimal. For this to work, the quotient left of the assignment operator must also be of type decimal, and at least one of the numbers being so this, the variable must be of type decimal, and then something, either the, what's it called, dividend or divisor, must be decimal. However, the following lines of code won't work because it's an int, because it's an int, because it's an int, and because it's, even though it's decimal, it doesn't have a decimal divisor or dividend or divisor. Add code to cast results of integer division. What if you are not working with literal values? In other words, what if you need to divide two variables? Oh, okay, and that's right, casting happens with the type in parentheses prepended onto the variable. Okay, that all makes sense. Why can I not? Oh my god. Yes. You've seen three uses for method operator, or for parentheses. Method invocation, order of operations, and casting. Yep, good to keep that in mind. Write code to determine the remainder, so that's modulus. Modulus operator, %, tells you the remainder of int division. What you really learn from this is whether one number is divisible by another, like also just even odd. This can be useful during long processing operations when looping through hundreds of thousands of data records and you want to provide feedback to the user after every 100 records have been processed. So modulus of 2 divided by 5 is 0 and 2. Yeah, 0 and 2. Order of operations, yeah. Please excuse my dear Aunt Sally. Write code to exercise C's order of operations. So 23, 35. Yep, makes sense. Use the operators. Okay, so from basic arithmetic, everything we learned about division. If you divide ints that do not divide evenly, then you will get a truncated integer quotient. If you want to get a decimal result, you're going to have to, the variable has to be of type decimal, and either the divisor or the dividend has to be of type decimal. To perform a cast operation temporarily, treat the value if it was a different data type. That's by putting the type in parentheses and prepending, modulus operator, and order of operations. And here we're going to talk about increment and decrement. Frequently you'll need to increment and or decrement values, especially for loops. So plus equals adds and assigns the value on the right to the value on the left. 0 plus 5 is 5. 5 plus 5 is 10. 10. Increment by 1. These same techniques can be used for subtraction, multiplication, and more. Yeah. Compound assignment. Alright, code. I'm just like literally just gonna read through these. I don't need to run them all. So starting with 1. So then that's 2. That's 3. That's 4. So 2, 3, 4, 3, 2, 0. No, 1. 2, 3, 4, 3, 2, 1. Yeah. The second increment that you used was plus equals 1, but yeah, you could have also used like the plus plus, but this plus plus is always 1. This you can use with any number. Got it. Position the increment and decrement operators. Both the increment and decrement operators have an interesting quality. Depending on their position, they perform their oh, that's right, yeah. This is always weird. So depending on their position, they perform their operation either before or after they retrieve their value. In other words, if you use the operator before the value, as in plus value, then the increment will happen before its value is retrieved. Likewise, value plus plus will increment the value after. Interesting. Okay. So let's see what value is 1. 1 plus 1, 2. So first is 1. Well, no, because we've done this after an incrementing. First is 2. Second is 2, and then 3. Third is 3. And then fourth is 3 in the string, but in the next line it will be 4. So 2, 3, 3. Here is 3 before. Nope, messed it up. Okay. First is 2. Second is 2, but then incremented. So 2 shows up in the string, but the value after the line is 3, which shows up as 3. And then we get down to here and it increments first, and then 4. Second. Retrieve the current value and use that in the string interpolation, then increment. Got it. Contrast, consider this line of code which increments first, and then that's what's reflected in the string, in the value interpolated into the string. While not strictly necessary, you add parentheses. Seeing so many plus operators next to each other seems like it could be misunderstood by other developers. Okay. So compound. Okay, converting Fahrenheit to Celsius. In this challenge, you'll write code that will use a formula to convert a temperature from degrees Fahrenheit to Celsius, and then print that message to the user. So clear the terminal and enter the following code. .94 Fahrenheit. Yep. To convert temperatures in degrees Fahrenheit to Celsius, first subtract 32, then multiply by 5/9. Display the result of the temperature conversion in a formatted message. Okay, so there's no inputs, it's just literally that temperature. So 5/9, that means this needs to be decimal. Is that how you spell it? Celsius. So first subtract. It's not picking it up. It's minus 32 divided by 5/9. That's going to give us a that's going to get truncated. Okay. I don't know if that'll. Yeah, it's not liking that. Or I wonder if it would work with that. No, it doesn't like that either. Okay, so display the results of the temperature conversion in a formatted message. Combine the variables with the literal strings passed into a series of console write commands to form the complete message. Once you're finished, the output should resemble. Ooh. So Celsius is going to be a double. Yeah. Still don't like this. Oh, it says you don't have to have all those. So then, why don't I just keep it decimal? Combine the variables with the literal strings. Okay. Well, that's not the correct. Multiply. Well, that's different. Yeah. Yep, okay, we did that. The following lines of code will output Windows 11. That's going to concatenate. That's just going to make 2. Oh, that will do it. What is the value of the following results? So 5 divided by 2 2 truncated plus 3 is 5. Result of it's going to go for int, truncate to int. And what following line of code uses the addition assignment operator? Alright, so basic operations, temperature conversion, overloading, plus sign and parentheses are overloaded. Okay. Calculate and print grade. So that is the project for this module, I believe. Okay, so there's 2 guided projects. This is the first. Okay, so we are calculating and printing student grades. So with this, you'll be able to learn to develop basic applications by breaking down the work into smaller parts, identify appropriate data types for storing and working with variables, perform mathematical operations to determine results, and apply formatting techniques. Okay, so it's a project, but it's like a step-by-step thing. So developers do tasks and make software for people to do tasks, blah 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 blah. Suppose you're an assistant teacher at a school. They want you to develop an application that automates grading. The application uses all of the scored assignments for each student to calculate their current overall grade score for the class. The teacher also has to provide a required format for reporting student grades. This module will guide you step by step to create your student grading application. Your code will declare and assign values to variables based on student names, perform various numeric calculations, and display the result. Calculations include determining the sum of scores and calculating current grades for each student. Yep. All right, let's do it. All right. So they give us some students and some grades, and presumably this is just for one class, like one subject. You're given a short list of 4 students and their 5 assignments. Each assignment is expressed as an integer 0 to 100. Final scores are the average of the 5 assignments. You need to perform basic math operations to calculate final grades for each student. Your application needs to output display each student's name and final score. Currently, the student's gradebook shows the grade assignments for each student as follows. The teacher requires, so it's just their name and an array or list of numbers. They want an average in decimal form with a letter grade, and that's set up like nice columns. Okay, so use the following steps to prepare the guided project exercises. So here are the grades. All right, number of assignments so that you can average. Each grade is a variable. Okay, so just copy this in. And not even any output. Next. Alright, you'll use the assignment scores for each student to calculate their current grade. To perform this calculation, sum the values of the, so just get an average. Create variables to store the sum. In this task, you'll create a variable for each student. We haven't even covered loops yet. We haven't covered any data structures. Oh God, this is going to be very monotonous. Okay. Um, so in this task, you'll have created a variable for each student that will represent their sum, the sum of their assignment scores. So you'll display the student sum along with their name in the console. So yeah, initialize variables, grade assignments. To declare an integer variable for each student you can use to sum their scores. Notice that 0 is assigned to the variables as part of the declaration statement. In other words, the variables are initialized to 0, right? Because we're going to be adding to each. To create a console, write lines statements that display the student's name and the values of their summed assignment scores. Enter the following. Ultimately, you want to display the student's overall grade, but for right now, use these console write line statements to display the value of your sum calculations. That way you can check to see if your code is working correctly at each stage of development. More advanced developer environments such as Visual Studio Code provide tools that enable developers to observe the values of application variables while their code is running. Learning how to use those tools saves professional developers lots of time during development. For now, though, you can use WriteLine to help verify that your code is working as expected. The current numeric value is automatically retrieved by referencing the variable name. I'm sorry, this is just so monotonous that I'm just gonna paste it. So at this point, we haven't summed anything yet. We haven't averaged anything. So these should all just say 0. Yes. So we're literally just going to, yeah, add them. Ugh, okay. Okay. Those numbers match up. So now we have to calculate the average. Let's just guess. So this is a decimal. Sophia equals I'm just making one of these. One of these be decimal so that the division can happen correctly. What's it called? Current assignments. Yeah. Am I forgetting how to do this? I should be able to cast this. Is it the divisor that has to be? That's weird. I could have sworn that one of these... Like, I can't just put an M on the end of it. Yep, and then that got truncated. I'm kind of curious how they want to do that. Yep, all truncated, all truncated. I'm curious, just like... Oh, okay, a space to say all of it after. Okay, gotcha. Now that makes sense. Okay, so we've calculated the sum, calculated the average. Those look about right. So now we have to do letter grades. And so first of all, understand 94.6, 83.6, 83.4, 95.8. Alright, so now the next thing is, oh, we're not even calculating the ranges. We're just literally appending it. Okay. A, B, B, A. No plus sign, A. How does the formatting? We don't have straight columns yet, but we can work on that. Okay, so now we are, I guess, going to do some formatting. Yep. Alright, next this task you'll apply finishing touches to the reported output. Start by adding a header row that includes the column labels specified by the teacher. After that, you'll use character escape sequences to add extra padding. So, yeah, just a header. Notice that you're including the /n to give it the extra space. And extra line, I should say. And then your output is aligned as columns of text. Replace the spaces between the words with the tab. Okay, so that's interesting. So the tab, well, let's do it first. So we're going to put tabs after every name, and then tab before every letter grade. Yeah. So the difference in I feel like I'm missing something. No, not yet. One, two, three, four. Okay, so the tab will just put space out to the next tab. So Sophia is 1, 2, 3, 4, 5, 6, 7, 8. So the tab will push the grade out to the 9th column, because that's 2 4-space tabs. But for Nicholas, since we already end at the 9th column, another tab extends it out a further 4. Okay. Notice that despite using a tab instead of space characters, some lines still don't have as much white space between the student name and their numeric code. The difference is due to the way that tab spacing is applied. Tab stop locations are set at 4-character intervals, and each tab will advance to the next tab stop location. If you have a string of 5 characters followed by a tab sequence, the escape sequence will advance to the tab stop at the 8th character location, filling the gap with space characters to create white space in the output. However, if you advance to the same location, you can advance to the same location if you have a string of 7 characters followed by a tab escape sequence. This makes tab sequences more noticeable when they occur further from the next tab stop location. To make white space more noticeable between the first two columns, add another T after the two shorter student names. Okay, so we're just manually going to push them out an extra tab. Push these two out because they are the shorter names. Okay. Check your work. Should look like, yeah, okay, so all the grades, calculating the averages, and printing it out. And these have double tabs. Well, these do not. And then you get, as expected, oh, also extra tab here. And all right, knowledge check. What does the following accomplish? So these are going to be ints. They're going to divide, and it's going to be a truncated int. Cast the operations to truncate the result. What does the $ symbol do when used in the string? You allow you to use string interpolation. What's wrong with the following code? Sophia. Okay, so it's an int, and then we are concatenating it. Oh, it wasn't initialized. Yeah. Okay, so now we're on the last module of this write your first code using C# learning path, and that's going to be the guided project for calculating a GPA. So with this one, the objective is, it's actually pretty much the same as the last one, breaking applications into parts, working with types, mathematical operations, and formatting text. Okay, so we are now at this introduction part. Again, it's actually a lot of the same summary or scenario as before. You're like a teaching assistant. You've been asked to do a calculation or make an application for the teacher. Before, it was about like calculating a grade for a class. This one is about calculating student GPA. The objectives are the same as before: working with variables, working with data, math operations, and formatting. Okay, so yeah, again, this before it was about multiple grades to determine, or sorry, multiple assignment grades to determine the grade for a class. This is about multiple class grades to determine the GPA for the student. So this is the output that it's supposed to come with. We're going to have class names or course names, the grades that they get, and then the credit hours. So they're obviously going to, okay, and it's one student. So we get this one student's course grades. Okay, so create variables to store the grade values. In this task, you'll identify the numeric equivalents for the students' earned letter grades. Letter grades, yeah. You'll then declare the variables to store the numeric grade for each class. Numeric equivalents are represented as whole numbers, so you'll be using the integer data type to store those values. So we have, from the last section, course names, course credits. Then we need to determine what the integer value is of the letter grades. So grade A is 4, grade B is 3. We're not defining the lower ones. This is a good student. So notice the fixed values are used to represent the numeric grades. This technique helps make your code easy to understand and prevent typos if you need to enter different grades repeatedly. Values for grades D, yeah, they're not using them because they're not using them. To create variables to store the grades for each course. Now here's where we actually give her grades. So in English, she got a B. That's what the credit is. No. And that's the units. This is the units. This is the grade. Okay. Yep, I got turned around a little bit. So this is like a 3-unit course, 3-unit course, 4-unit course. Okay. Then these are the grades. So display the course name along with the numeric grade. Write the following. Okay. And then, okay, and then just credit hours. Yep, that's the same. So now we're actually going to start doing some calculations. So we're going to add another column for grade point. Alright, so in this exercise you'll calculate and store the total number of credit hours and the total grade points for each course. These values will later be used to calculate the GPA. Since both the credit hours and grade values are represented as whole numbers, you'll store the sums as the integer data type. Recall that to calculate a student's GPA, you need the total number of credit hours and the total number of grade points. Yeah. Total number of credit hours, total number of grade points. The grade points you earned for a course is equal to the product of the number of credit hours credit hour, credit grade point. Okay, credit hour, and then what we're about to calculate will be a third column here, credit grade point. Okay, the grade points earned for a course is the product of the number of credit hours for that course and the numeric grade value earned. So in this task, you'll create the variables to store the values needed to calculate the GPA. You'll create a variable to store the sum of the total credit hours for each course, and another variable to store the sum of the total grade points. In the editor, you're going to use console write line statements. Create a blank line above the console write line statements. on the blank code line you created, in the editor, just make a blank line. And make the total credit hours, starting with 0. To increment the sum to represent the total number of credit hours, enter the following code. So the credit hours start at 0, and then for each course for this student, we add the course credit. God, I wish we were using loops at this point. So now it equals itself plus the additional value. These lines of code have the same result of adding each course credit on one line, each course credit variable on one line. So to create a variable that will store the total number of grade points earned for each course, enter the following. To increment the sum by the total number of grade points for the first course. So grade points equals course credit times course grade. So that's for course 1. 4 times 3. And that's the 12. Okay. Notice that the code you write breaks down the problem into manageable pieces rather than trying to calculate the GPA in one large operation. First, you initialized and calculated the value of total credit hours. Then you initialized and calculated the value of total grade points. Afterwards, you'll use the values in your final calculation. Now that your code is calculating the value for total grade points, let's verify that your calculations are correct before continuing. To display the value of total grade points and total credit hours, is the number correct? 5717. Yep. Format the decimal output. In this exercise, you'll calculate the final GPA and modify the console output to achieve the desired reporting format. The GPA is equal to the sum of the total grade points divided by the sum of the total credit hours. So we're going to remove this debugging statement. But we're still going to keep an additional line here, because that's where you're going to do the GPA, and since it's going to be a float, it's a decimal, we initialize we declare and initialize grade point average. When you want, okay, yeah, because we want the results. Oh, that's right, because this is an int and an int, so we need to cast this. So now we are going to print the actual GPA. Alright, and it's like too long. What did you do? How did they do that? If you're not using a suffix. format the decimal output. Okay. You might have noticed that the decimal contains many more digits than the standard GPA. In this task, you'll manipulate the GPA value so you only have 3 digits displayed. Ultimately, you want to display the first digit of the GPA, a decimal point, followed by the first 2 digits after the decimal. You can achieve this format by using variables to store the leading and trailing digits respectively, and then printing them together using console write line. You can use math operations you learned to extract the leading and trailing digits. Okay, thank God. You'll eventually discover built-in operations that automatically apply formatting to your data. But for now, this is an opportunity to solidify what you've learned so far. Alright, navigate to the top of the console, write line statements. Create a blank code line above console write line statements. The leading digit is grade point average. So let me guess how they're going to try to want to do this. I guess they're showing it right there. So when you cast to int, that's going to truncate so that you have the whole number, the tens place component. So how do you get the trailing? Because it's not just modulus, because that just gives you the remainder. Interesting. Yeah, I'm not sure what they're going to say to do. Oh, okay. Okay, that makes sense. Notice that to extract the leading digit from the decimal, you're casting it to an integer. This is a simple and reliable method for casting a fractional value. Will never round up to the result, meaning that if the GPA is 2.9, casting a decimal value to an int will result in 2. To initialize a variable that will store the first 2 digits after the decimal, enter the following code. So grade point average, like 2.99, times 10, 299, modulo 10, which will leave the 99, and then int. So 2 and 99, and then you just concatenate those with a period. So if you take 299, yeah. Yep. Oh, it gives you literally the first digits. Oh my God, I kind of hate this. So 299.4573 divided by 10, or modulo 10. So that means 99.4573. And if you got a 99, wait, why are we, where are you arbitrarily just getting 29 from? Okay, so this is it broken out into the literal steps. So this is the 20. Okay, so this is this broken out into steps. Okay, so we take okay, not 299, 29. I bad with math numbers. Okay, 29.94573. Casting to an int truncates the decimal. Now it's 29. 29 modulo 10, which leaves a remainder of 9. Okay, I'm back in sanity land. So that's the first number. And then the second number, second digit, 2.99. Okay, so 2.99, that's the 299 modulo 10. Which is just going to leave 9. 299 modulo 10 leaves 9. To correct the final GPA. To correct the final GPA output, we're going to do this now. 3.35. So I'm sure there's some formatting to do. In this exercise, you'll modify the console output to achieve the specific formatting. Alright, so here we are. Okay, we're just giving it a header. The extra new line to create a line between them, between the name and the rest of the output. On the blank line you created, create a header. So course, multiple tabs. I think we're just manually putting in enough tabs to account for the longest course name. Then grade, then credit hours. Yep. And then we're not doing it really intelligently here. We're just kind of making it fit. Actually, let's just do like there's a fifth course. Oh, there it is. Because it really doesn't need to. Yeah, it just needs one. Start it off with a new line. KK. Check your knowledge. Suppose decimal grade point average 399 blah 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 blah. What's the value of an int? Casting to int is 3. Okay. And then decimal. So because these two are ints, the truncating is going to happen even though the decimal is, x is typed as decimal. Okay. Alright, cool. So next we're just going to, and this will be for the next video, we will do, let me complete this. Oh, it was this trophy thing. Now that you've completed all your write your first code using C# challenges, you should have earned a trophy for it on the Microsoft Learning Platform. If you don't see this trophy when viewing your achievement page, you have not completed all the tasks. Well, I'm glad I looked. I don't see anything about a trophy. Okay. Oh, yeah, trophy. Badge, 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 badge. Link your Microsoft username to your freeCodeCamp account and click the View Trophy button below to complete the challenge. To complete this challenge, you must first link your Microsoft username to your freeCodeCamp account by using the following instructions. Using a browser, when you're logged in the Microsoft account, go to Transcript, where I just was. Copy the link button, or no, find and click the Share Link button. Copy link. Paste your transcript link. View trophy. I said view trophy, not view add. Okay, your trophy was verified. Okay. Alright, so for the next video, I will be doing this second module. So we'll actually be in Visual Studio Code going forward. And I don't know, it's just more console stuff. Okay, using branching logic, if else, code convention, white space. So kind of the next step. And looks like we'll start dealing with arrays. So I can hopefully start making things that are a little more substantive. But anyway, yeah, thank you for joining me if you somehow made it to the end. And otherwise, I will see you in the next video. Have a good one.